Now we're going to look at fictitious play. As opposed to Nash's equilibrium, fictitious play is used for larger games. So I just wrote a simple 3x3 game here, and we're just going to go through the steps. We're going to select a row and write it below. So just to start off, I'm going to give you the row, and I'm going to say, let's take row A2. So just keep in mind, this was given. All right, so when you go back and look at this, you're fine with it. All right, so then what we do is circle the minimum and write its column to the right. So the minimum is 3, because 3 is less than 5 and less than 6. Its column is B1 here. So we write B1 to the right. All right, so that's 1 and 2. We circle the maximum. So when we go to the right, it's the maximum. When we go to below, it's the minimum. And we take this column and we add it to the, take this row and we add it to the row we already have and write the results. 6 plus 3 is 9. 4 plus 5 is 9. 5 plus 6 is 11. All right. Now we have to circle the minimum and add the sum to the right. But we have a tie here. We have 2 that are the same. So I'm just going to temporarily jump down to 6, and it says break ties randomly. We're going to set the rule that with a tie, we're either going to move to the right or move down, depending upon if it's a row or a column we're talking about. So in this case, to break this tie, I'm going to circle 9. But again, that's because we set this rule here. If you played the game long enough, it really wouldn't matter which one you circled, but I only want to do the game 5 iterations. All right, so we take the minimum and we add it to the right. So this is the column associated with their minimum. So 7 plus 5 is 12. 5 plus 3 is 8. 4 plus 6 is 10. We come down here and we repeat 3 and 4 until finished. I want to do this game's 5 iterations. So we've done 2 now. So I circle the 12. 5 plus 9 is 14. 7 plus 9 is 16. 4 plus 11 is 15. I circle the minimum. I take this column, I add it to my existing column. So I have 17, 11, and 16. I have the maximum, I circle that. 4 plus 15 is 19. 7 and 16 is 23. And 19. Again, we go back to our rule here. To break ties, we set the rule that we're going to the right. So I'm going to circle 19 there. Excuse me. So we take this column, we add it out here. 21, 17, and 21. We've also set the rule that if it's, will go down if there's a tie. So we're setting this because of our rule here. And this would have to be part of the information you were given. 25, 27, and 24. Again, this is my last time through. I circle it. I take the column, so this is 25, this is 23, and this is 26. All right, so I gave you that I wanted you to go through this game 5 times. So we could figure out how much of the time each strategy should be played. We have 5 iterations, 1, 2, 3, 4, 5. So B1 should be played 2/5 of the time. B2 should be played 1/5 of the time. And B3 should be played 2/5 of the time. And that's what's meant by number 7 here. Find playing frequencies by the percent of time played. So, through 5 iterations, the 5 comes from the 5 iterations, you know, we played this one 2 times, or 2/5, 1/5, 2/5. We can do the same thing for strategies A1 and 2 and 3. 2/5, 0/5 or 0, and 3/5. So we have our playing frequencies there. So the maximizing player should play this strategy A 2/5 of the time, and strategy 3/5 of the time. The last thing we need to do is find the game value. We find the game value by taking the last 2 numbers played and dividing them by the number of iterations. So we know our game for this, the last number played is 24. I'll put this game value. Excuse me. Game value. All right, we know our game value is going to be in a range. The low end of the range is 24, and it's divided by the number of iterations. We played this 5 times. The high end is our last number played is 26. Again, the 5 iterations. So our game value will be between these 2 values.